Alright, so in this video we're going to have to use the quadratic formula again. So we're going to generate a quadratic equation where we substitute it into our equilibrium expression. We solve that equation using the quadratic formula. In this case, the quadratic formula yields two positive values for x. If you remember the last example, one of the values was negative. We can exclude that immediately because you cannot have a negative concentration. In this case, both values are positive, so we simply have to decide which value is going to be the value we use, because we cannot have two different equilibrium concentrations for the same species. It just doesn't work that way. So without further ado, let's get stuck into it and see what happens. So here's our question. Calculate the equilibrium concentrations given a value of Kc and initial concentrations of both reactants, carbon monoxide and chlorine gas. There's the equation you're going to work with. So let's get started here. So first thing we do, as we always do, is we generate an ice table. So here's our ice table and initial concentrations for our reactants. So 0.500 moles per liter and 1.00 moles per liter for carbon monoxide and chlorine. And again, the reaction hasn't started, so that's 0. In terms of change, well, it's going to change by x based on stoichiometry. It's going to change by x, and that's negative. And the product COCl2 is going to change by positive x, and therefore at equilibrium 0.500 minus x, 1.00 minus x, and x. So there are our equilibrium concentrations for this particular reaction. So now we can plug that into an equilibrium expression. So equilibrium expression is going to be, there it is there, COCl2 divided by CO times Cl2. And so we just do our usual plug and play, and there are our substitutions. And again, that careful algebra you are getting so good at gives you this quadratic equation. So there's our quadratic equation that we need to solve. In solving that, we're going to substitute into the quadratic formula. There's the quadratic formula. Substitute in. And when you do that substitution, when you solve that quadratic formula with that quadratic equation, there are your two values of x. So as I said, two possible values of x. And so which one is it? 2.79 or 0.176? Well, you just have to recall that for our solving of our concentrations, so our concentration or product, this is our product. So that's x, so it could be either one, but if we look here, these two are our reactants. And for our reactants, 0.5 minus x, 1 minus x, we'll look at our values down here of x. So we cannot use 2.79. X equals 2.79, 0.5 minus 2.7, negative concentration. 1 minus 2.7, negative concentration. So we can dismiss 2.79 as yielding negative concentrations. So this is our value of x. So we're just going to do that. So COCl2 concentration equals x. So that equals 0.176 moles per liter. And the concentration of carbon monoxide is 0.50 minus x, so minus 0.176, and so that equals 0.324 moles per liter. And our concentration of chlorine gas, Cl2, is 1.0 minus x. And so that equals 0.824 moles per liter. So pretty straightforward. Again, you have to be very careful in finding your quadratic equation. That's up here. And you have to be very careful in solving when you plug in and getting your values of x. But once you get your values of x, one of them will easily be dismissed because it is going to yield a negative concentration, which you know you cannot have. So that concludes this video.